All right, good afternoon and welcome to our second research conversation of this fall 2024 semester. My name is Shola Adiso. I'm the Associate Dean for Research here in the College of Education. Today, I have such a great privilege of introducing our speaker, Dr. Tingting Li, to you. Dr. Li is an Assistant Professor of Science Education here in the College of Education. She's here on the Pullman campus. She received a PhD from Michigan State University in Educational Psychology and Educational Technology. And she also has a second PhD in Curriculum and Instruction from Northeast Normal University. Our research explores the underlying complex learning processes of building usable knowledge and how student engagement interacts with this process by leveraging state-of-the-art technologies such as artificial intelligence. Dr. Li designs learning environments and assessments that support students' usable knowledge building as well as their psychological well-being, for example, engagement as well as social and emotional learning. Today, Dr. Li will speak on artificial intelligence and elementary science teaching and learning. She will share insights from her research on AI-enhanced elementary science teaching and learning, drawing from several recent projects. Please join me in welcoming Dr. Tingting Li as our research conversation speaker today. This is our very first semester. Dr. Li, thank you. In WSU, thank you so very much for joining us today.
Thank you so much, Shola, for the really nice introduction. And thank you so much, Laura, AJ, and Shola for having me here today. So I'm very excited to talk to you all about my recent research on artificial intelligence and elementary science education. Let me share my screen. Can you see my screen?
Okay. Yes, we can see your screen.
Oh. Yeah, so I want to start my conversation with you about the recent the Nobel Prize. I think AI, you may hear AI every day. Everywhere is AI, right? Especially the recent Nobel Prize in chemistry, both chemistry and physics are all about artificial intelligence. Actually, they play a really critical role in the process of science work. And then, then this AI has been everywhere. How AI could kind of affect or influence our education field. And then for today, my talk, I'm very excited to share with you my recent work about AI for science education. I will start my conversation about what is AI, especially my positionality of AI in education. And also how what AI can do for science education or for education. I will particularly introduce AI for automatic analysis and timely feedback, and AI for adaptive design. Throughout of my talk, I will also talk about what should we consider when we're using AI in education beyond just efficiency. So I think it's important to talk about what is AI. So you may see a lot of kind of work that are talking about artificial intelligence, but it's really critical for me to define AI in different research work. How do you think about AI? What kind of AI technology you are using for your research? So simply speaking, AI is the combination, not simple, combination of artificial and intelligence, which aim to achieve the train the machine to have the ability like a human being that can learn and solve problems. So in this case, they want the machine to be able to solve problems like a human, to act rationally and act like human beings. And then this diagram shows the subset of AI and also the subset of AI utilized in my research. So one part of my research work has been using machine learning. Pretty much most are supervised machine learning, which aim to give a computer the ability to learn from existing data without being explicitly programmed. Making the computer has the similar ability, that more similar to human, like in their ability to learn. And also another part of my work has been utilizing deep learning, which is a subset of machine learning that use artificial neural networks with multi-layers to automatically learn patterns from large data set. This is especially important technique for image data analysis. In the rest of my, somewhere of my talk, I will talk about how I utilize this technique in my research work. And then, so another part of the my work is about generative AI, especially after the OpenAI released the ChatGPT since 2022. Then, so generative AI become a really important kind of the interface or chatbot. The ChatGPT becomes an important chatbot for various people kind of interact with these type of new technologies. And then, so for generative AI, it is different from the traditional machine learning or deep learning. It can generate new data, generate original content or information based upon what they have been trained on. For instance, like ChatGPT is a large language model based chatbot, which has been trained. They use the OpenAI, the engineer, they use the data from Google and also Wikipedia, all those extensive data to train the large language model to ensure it has the in-context learning ability that can respond to your prompt, your question, using their in-context learning ability to respond to you like a human being. And then, so as I mentioned before, it's also important to talk about how do you define AI in your work, not only from the technique perspective, not only from what are machine learning, what are deep learning, but how do you see AI in my work? So in my work, I draw on relational epistemology from the social material perspective to conceptualize AI in my work. Pretty much, I see AI is defined in my work is defined by the context-bound relationship between humans and computational artifacts during specific interactions. So in this case, AI in my research work is not only a computational approach. I more emphasize the human technology interaction. And I also see AI as the cognitive amplifier, as one type of digital tool that can extend or reshape human thinking and collaboration. So which is built on the cognitive, distributed cognition theory. So that's emphasize the complex cognitive processes are not only confined to individual, but also distributed across people, across objects, and also the environment that it involved in. Yeah, and in my work, I strongly believe that we should bring human into the loop or AI into the loop, even AI into the loop to achieve the human-AI collaboration to build the hybrid intelligence system to achieve our educational goals. I want to set this kind of foundation for you to kind of further understand the rest of my research work. So what can AI do for education, building from there? So, and what have we done for using AI in science education? So for those of you who may not familiar with science education, so since 2012, the US released the framework for K-12 science education, the new science education standards, and which shift from the original emphasize factual knowledge learning to scientific proficiency development, which we call knowledge in use or usable knowledge. That requires our students should be able to apply what they learned in the classroom to solve complex problems or explain real world phenomena. They want our kids can use science to make their life better, to think why they learn science, what can they do use science in a more scientifically and ethically. And then, so in this case, supporting student science learning really need the further support from the coherent assessment system So when I talk about assessment in my work, they are not only they are not assessment for evaluation, they are assessment for learning or even assessment for as learning. So those assessments are more are usually used in their classroom formatively to collect the student learning experience to support the teacher to understand whether their students are developing usable knowledge. If they are, where they are in the developing processes. If they are not, what kind of challenge they may encounter, and how we can, as teacher, to navigate, to support them to navigate through the challenges. So give you a kind of brief kind of the some kind of brief introduction about this is one kind of performance expectation from our standard. So under this simple brief statement, you can see that there is actually three dimensions. And when we design either learning curriculum materials, lesson plans, or assessment, so in the visible part of the performance expectation, you can only see this very short, brief description statement. But underneath of the visible part, there's a lot of kind of other aspect we want to consider, like the equity, like the various different aspect of DCI, the three dimensions and other student proficiency, prior knowledge, this kind of thing. This diagram, I want to show you the complexity of unpacking and designing curriculum material to support student science learning. So I already kind of mentioned it a little bit. Then how can we design this type of assessment or learning activities, materials to effectively collect evidence to support or understand where our students are? And also, how can we ensure those tasks are equitable and inclusive for all of our students? Even more, how can we support our teachers in designing or adapting existing curriculum materials or assessment tasks to support their student, their progress toward developing useful knowledge? This slide show you one example of the assessment task that we designed for our middle school student. This is the computer-based assessment task. And then this is we ask our students to draw a model and provide an explanation about their, how to explain this phenomenon they watched in the video. And then this is one student responses. And this is another kind of student response to the same question task. And this is the third kind of we have a ton of kind of student responses to this type of, to this assessment task. We designed more than 200 assessment tasks from elementary to middle school level to support the student to provide this material for teacher to use in their classroom. I show you this student example want to have you here to understand the complexity of this type of assessment task and also the challenge of understanding or analyzing this type of student task. So because you want to not only look at their model, but also look at their explanation and combine the information both from the model and from the explanation to comprehensively understand what kind of understanding your student have now. And then this is the rubric we designed to help us to understand, to analyze student model. You can take a moment to imagine if you are the teacher, if you have 20 students in your classroom, and then each student submit their response to the system, and then how long it may take for you to analyze the student model and then their explanation. It's very time consuming. And also it's challenging because the analyzing model, scientific model explanation is not easy for a lot of teachers. And then this is another paper pencil assessment task. We have one task we have in the elementary science classroom. That's the post-unit assessment. So this is paper pencil. You can see this response is our real student response from the third grade student. So they draw this kind of the model to show their understanding, make their prediction about what's gonna happen to these squirrels who lived in this area if someone cut down all of the trees in this area. So this is about adaptation, the survival, and also the cause and effect. And then, so for the student also write down their explanation to their model. And then these are the other kind of the student models. They all kind of respond to the same question that I showed you before. You can see it gives even greater challenge due to the increased freedom and flexibility.
There, I'm gonna Zoom. What's up?
In
Well, is it a quick, I'm actually on, like my camera's turned off right now, so is it something really quick?
Yeah, so let's keep going. Yeah, so if you see this model, you may see that it actually kind of add a greater challenge given compared to the computer-based model. Those hand-drawn model, actually paper pencil model, has more freedom and flexibility in expressing their student ideas, right? And then so this is the rubric that we use for analyze the paper pencil model. And then, so I said before about that. So this is the analysis process is very time consuming. And if the teacher cannot analyze their student model, so they cannot provide timely feedback for their students, and they may not understand where their students are, and then which may affect their instructional decision for their following instructional activities, right? Activities. And then, so building on that, part of my work is using machine learning and deep learning for automatically analyze student artifact, pretty much like the written responses, the student explanation that you saw before in both the computer-based model and the hand-drawn and the paper pencil model. And then, so this is we use machine learning, pretty much BERT approach to automatically analyze constructive written responses for student explanations and other written responses, constructive written responses. I can open it up if you have any question later, so if we have time. So this is another part that I use deep learning to automatically analyze student hand-drawn models, those picture model. That's what I introduced before when I talk about deep learning. It's a very important technique for analyzing image data. So I use convolutional neural network to achieve the goal. It learns from multi-layers and then form the feature factor, and then make the prediction about the model, about the student, their responses. So for when I did the work, that I was thinking, okay, so using AI can save time, save money, and even effort, right? It can help us to understand student learning, to support a teacher in making timely decision to support their student learning. But using AI may introduce some biases, particularly affecting some like if your trained data is not balanced, the machine can only learn from the majority of the data categories. It may ignore the student responses in the minor, in the kind of the smaller data set. Let's take a case like the multilingual learners, right? And then, so a lot of people talk about the junk in and junk out. That's what I said before. If the training data set you feed the machine is not balanced, or is not even distributed enough, right? And then it may lead to some biased prediction. If you use the algorithm you trained using the data you feed in. Then, so it's aligned with one of the research work we have done about, we actually intentionally pull out all those multilingual learners, their models and their explanations. And then we invite our experienced teachers into the loop to ask a teacher to evaluate the student model, to analyze this model, these English language learners, their student model, and compare the teacher's model to the machine predicted scores, the teacher's score, and then the machine's predicted score. And then we found that our AI tended to favor mid-range scores, while teacher provide a broader score, range. So this is very interesting. And then we dive into, we are in the process diving into the qualitative analysis to try to understand what are the various kind of the aspect that our teachers are considering when they try to analyze or understand those student models, on what cause these kind of the differences. And then so I'm very happy. So I'm very excited to kind of initiate this conversation with my colleague together in science education field. Then when we use AI, we should use AI be culturally and linguistically responsive to teaching and learning beyond just the efficiency. And then, so one way that we can do is to bring humans into the loop, especially our experienced teachers. So that led to my dissertation study about the cognitive synergy. I try to explore the transformative intersection of human intelligence and artificial intelligence in designing equitable next generation science assessment. So I'm also kind of proud and lucky to be the semi-finalist of National Academy of Education Spencer Dissertation Fellowship list for my dissertation work. And then, so this actually, my dissertation actually also kind of based upon the conversation or the experience, my interaction with a lot of teachers. We provide those assessments that we designed for them. And then typically they shared with us that those assessments, sometimes they have to adapt or modify it a lot. Because either the phenomena may not align with their classroom, their local community, like their phenomenon, their resources, or the assessment, they need to adjust the language level a little bit to make sure students in their classroom who have different reading abilities can be accessible to the assessment. So overall, teachers, they provide feedback that they want some assessment that can be more adaptive. And then, so which can be, used for their students with diverse needs. For instance, if the assessment, they can kind of, do a little bit of modification to ensure the assessment can be used for their students, like their multilingual learners, their students with different cultural backgrounds. And then they can bring their local community phenomena or resources into the assessment or the learning activity design to ensure those learning activities or assessment are relevant or meaningful to their student. So then in my dissertation work, then I use generative AI to achieve this adaptive design feedback that I received, a goal that I received from the teachers. So this is the design model that I have in my dissertation. So I know this is a very busy slide. I will not kind of open it up. So the nature of this work is to bring human and the AI together to try to amplify the computing power of the generative AI. In my case, it's like large language model. And then the human power of the self-regulated learning and this part together to achieve this complex design goal. This is my research design. So I have 3 stages. The first stage, I use OpenAI API to the overall design is design-based research, and the analysis is mixed methods approach. And then, so there are 3 major stages. This is too small. I did not expect you to kind of, to read it through, that I can open it up. So this is the stage 1. I first set up the initial, I use OpenAI API, the application programming interface, to set up the environment for training the algorithm by leveraging the computing power of large language model to achieve, to give the prompts, the engineering prompt, to achieve the goal of designing different various products of the assessment. And then after I design the task, the assessment, then I form the interdisciplinary expert panel to provide external review and refinement. So this panel, the people on the panel list, they have various different expertise. For instance, I have assessment expert, I have not a science content expert, language expert, engagement expert, and also they provide different kind of perspectives. They provide feedback from their own perspective. Then third stage, I incorporate their feedback to refine the original design through incorporate their feedback into the algorithm development. So this is one task that I use the algorithm designed to design for the third grade student. And then this is the first round task without expert panel feedback. And then so this heat map show the expert panel feedback, the numerical the numbers of their feedback. And then so they provide so the x-axis is the different expert group, and the y-axis is the dimensions they provide feedback on. And then from the blue color to the red color, you can see these are so those blue colors are the area that need further revision. And then when I did my refinement processes, I particularly focus on the revising these various part. For instance, here is the this one talks about the phenomenon. So the NGS expert, the standard expert feels like the phenomenon is not very compelling enough. But it's very interesting that some other experts feel like, oh, it's fine, it's good. Like the engagement expert give 4. So it means the engagement expert feel like it's good, it's nice. So the phenomenon is fine. So that's also led to some kind of the limitation or discussion in my research about how do I kind of, deal with or handle with this discrepancy among the different experts' feedback, especially when they have very different feedback. And this is the iterative refine process that I show here. The model is from after, this is my first round design product. And then, so after I have this product, then I collect my expert feedback. And then this part shows the how the feedback is incorporated into the refinement process, and then finally produce the second round design product. And then the second round design product were also sent out for the expert for their review. So this actually is the refined assessment task in the second for the same learning goals. And then so I use scatter plot to show the improvement or the change or the difference between the first round and the second round expert feedback. So to make sure to understand whether my refinement or whether the AI and my refinement makes that improved or not throughout these refinement processes. You can see that there's the blue color dots represent the first round review, and the red color dots represent the second round. And then there is a noticeable improvement across these 2 rounds. So there are some main takeaways from my dissertation, simply speaking. So when we train the generative AI appropriately, or large language model appropriately, it acts like as a human partner to design these curriculum materials, which you can see the evidence from the expert feedback. But in the process, domain-specific information or knowledge and iterative refinement and revision are very critical. And also human plays a very critical role in these processes. So, so in my current work, so I am shifting from also considering the data privacy and ethic consideration, this perspective, I'm shifting from OpenAI's API to the more complex RAG system to ensure the data or the trained algorithm that can be used more safely, or and the student data that we collect, if the teacher use the system, the student data can be stored at a secure server. So instead of all of the data go to OpenAI, so which is not what we want. Yeah. So I think I'm going to stop here because the time consideration. So I want to summarize my kind of this very brief short talk about throughout my work, my recent work about AI and science teaching and learning. So one thing really stood out to me is how might the confluence of human intelligence and artificial intelligence can work together so to reshape the future of K-12 science education. So I would also kind of, I would also kind of encourage everyone to think about this question, and also I welcome the question and comments that you may have about my work. Thank you.
Thank you, Ting. I will take care of the question and answer session. And the way I do that is I start with a question myself to get us primed and ready to ask more questions. You had that slide where you talked about amplifying the reflection. And I noted that you had a human and a computer side to it. How is the amplification, do you include ethical considerations, the use of AI and so forth? Tell me a little bit more about what you mean by amplifying the reflection.
So thanks so much, AJ, for the really great question. So yeah, amplifying the reflection. So in my work, the amplifying part, so I emphasize a lot about the computing power of AI. So for instance, if as a human being, when I analyze my dissertation data, right? So I'm the person who analyzed all of the expert feedback, but I had a hard time to incorporating this feedback or into the refinement processes. Then how can I so in that process, I use AI, the generative AI, the power to it has the multi-agent system the multi-agent to play a different role in the system. For instance, I have the engagement agent, I have the equity agent, I have the assessment agent, the content agent. So this agent, so they can actually really kind of come debating with each other when we set up like a virtual platform for them to talk to each other. So this is one thing I can see is amplifying one part of the amplifying the reflection or the designment process, not only the reflection. Yeah.
Yeah, thank you. Appreciate
that. I respond to your question. Yeah.
Other questions?
This is Michael in Vancouver. Thank you. It was really interesting. I feel a bit overwhelmed. I've been using AI a little bit, and I feel like I've barely done less than 1%, and you're ahead of me like by 100 meters or so in the sprint. So there's so much to this and so much to know. You highlighted one question I had was, so I do a lot of writing research, so I have students' texts, and of course I don't want to include their names, but even their own phrases, paragraphs, like if I upload that to AI, am I giving AI all of this content? And you earlier said yes to that, but this other type of AI that you mentioned, Rock or AI or something, I've never heard of it. And is that free? Is that part of possibly Microsoft Copilot that the university provides to us? Does Microsoft Copilot take uploads and store it for its own use and sharing with other people? Like,
Yeah. So thank you so much, Michael, for the question. So I'm so sorry for making you feel like too overwhelmed from my presentation. Yeah. So yeah, so I mentioned before, if you are using ChatGPT, for instance, right, and then all of your data goes back to OpenAI, So those data will be stored for their further training, future training. For instance, you may notice that. So if you want to use more professional version like the GPT 4.0 at the beginning, you need to pay, right? You need to subscribe their service. And then later they opened on the GPT 4.0, and then now they have GPT 4 mini, and then GPT 01, those various different models you can use throughout ChatGPT. And then the reason why they are all free for you to use this new models because they want to collect more data from user. And then so the more user use their new model, the more data they're gonna collect, and then they're gonna retrain their model better. So that's their purpose. So all of the data you upload to ChatGPT goes to OpenAI's database. And then
what about Copilot?
what? Say again.
What about Copilot, the university provided one? Microsoft Copilot?
I'm not familiar with that one. I'm sorry about that. Yeah. So and then so what I talked before about the RAG is a model. It's also a model, but it's like more like the training processes. It's not about RAG. RAG is just the mechanism, but so the major part is when you use that if you so how to say that? So what kind of server your data gonna go to, that's the major part. So you want to have a server that can store your data securely, and also make sure they are not kind of shared by the server holder. And then so I know one kind of there's one platform called customgpt.ai. So this one you can allow you to upload the material that you want to use for your own task. For instance, if you want to analyze your student responses, right, you can give the custom GPT.ai document or instruction about. So now you are kind of instructor, and I want you to help me to analyze. You will analyze your student work, and then here are the criteria you want to refer to. Do not refer to any other data sources through the website or either Google or other kind of the resources. You can block that part. And then so all of your data, in that case, even you upload your student model, your student responses, your data will not be distributed to other people. So that is a secure one, safe one for me. Yeah.
Thank you.
Sure.
Great. Other questions?
Did you get any feedback from students at all regarding their thoughts on receiving like AI assessment feedback, for example? Like, I know elementary students are young, but I would think that maybe they, do they appreciate the value in that? Do they feel like their work is being overlooked? They're sitting there working on that assessment for, assuming they're putting a lot of effort into it, and then the teacher's not putting as much effort into grading it.
Thank you so much, Lauren, for the great question. Yes, it was initially in my research design. So I try to kind of bring students into the conversation. But nowadays, any research about AI, if you want to use AI for students, the IRB is really, really complex. Yeah, and also it took very long. you know, and then so because of my kind of time constraint, I did not kind of include the student into my my research work. But when I talked to the teacher, I do have expert teacher in my expert panel. So I actually not only have their feedback, but also interviewed them, several of them, about what do you think? How do you think your how would you think your student, they may kind of think about this kind of work? You know, I do have this kind of, you know, the data, try to understand the student. And then in one of my recent work that I'm applying a grant is also about bringing student. I really kind of bring students into my research design, try to kind of value their voice and their feedback about our work.
Thank you.
I have a question, and I think you might have, I think you touched on this, but I think I probably missed that part, or if you didn't, then when you're talking about how the based on the feedback that you had, you're talking about like the paper pencil kinds of assessments where students can actually just, you know, do things by hand and just like, you know, work on their tasks by hand, or where they use AI to do this. Was there any the feedback that was given, was there any preference for either one? As in, I know that you just mentioned that you didn't actually get information or feedback from students directly. But then is there any information that you can share about that? Like, was there any preference for, did this seem like those that did give you feedback, the experts that did give you feedback, was there any preference for students using like paper pencil to express themselves, or was there a preference for, would they rather just, you know, they think was just better for them to just use AI to sort of express themselves when it comes to assessments, if that makes sense?
Thank you, Portia, for your question. So we did not, so the teacher, they are totally fine for using AI generated or human AI collaboration designed assessment task. They found, they actually, a lot of my teachers, they found it's very helpful, and they want this kind of, you know, technology to help their life, to make their life easier. So the reason why is because the assessment that I was talking is not only for evaluation. I mentioned that, right? So we hope that assessment can be used as the classroom activity for student learning. So the teacher, but this type of assessment design, I mentioned a little bit, actually is very complex and systematic process. And usually it incorporates various different aspects, you know, the expertise. And the teacher is too overwhelmed for teacher to be able to design this type of, you know, this type of learning activities. And then, but they know the importance of this type of assessment or learning activity. And then, so they need some kind of extra support. They need extra support. If you are in the science education field, you may see that there's a lot of kind of workshops to train teacher to have the ability to equip the skill of designing three-dimensional learning activity or assessment task. I saw Lindsay nodding her head. Yeah. So yeah. So then we want our teacher can do that, but it's really challenging. It's very hard. And then the teacher, they actually really appreciate this type of work. No matter whether they are paper pencil or whether they are computer based, whether what the format is not important. The most important is whether those assessments can support their student three-dimensional learning. Yeah, I hope I respond to
You did, yes, you did. Thank you.
We have a question here from Patrick. Patrick, would you like to read your question that you posted in the chat?
Yes, I can revise it. Like, there are opportunities, for instance, with AI to provide nimble, in-the-moment assessments. Like, in a science instruction session, we could have like maybe say 5 students sharing different models that they, you know, that the teacher may utilize in instruction. But so my question is there a way that AI can be, you know, enhance the teacher's attention to the details of the student's model in a way that can guide instruction pliably, like in the moment?
Yes, correct. I did not kind of opened it up because we only have very short time, right? So that's actually one of the work that I worked on. I have been working on, that's the timely feedback. So the how to use AI to provide timely feedback for both our teacher and our student. So, but how those feedback was offered, how those feedback was offered is based upon the student performance. And then how do we know those performance is based upon their response to the assessment we provide for them, right? So, and then once we have the AI to help us analyze those student responses, and then it will automatically generate an auto report to both teachers and student. For teachers, it could be the overall classroom kind of report. How many % of your students achieve this part? How many % of your students failed to this part? And then so what kind of what could be the several kind of plausible action a decision, instructional activity that you can move forward to, and then it provides teacher these options to support their decision making in the moment. I think Peng will talk more about that. That's his major work in the AI field in the next kind of the talk. And in my work, so I designed the automatic feedback to provide the student timely feedback for their learning progress. For instance, if the student is developing a model, is drawing a model, but the student got stuck, and then the system gonna kind of automatically capture what's going on there and then provides, oh, you did a great job on this part, but have you ever think about that part? And then, give several kind of options. We try to make the feedback to be more constructive and productive. That's our goal. Yeah.
Thank you.
Well, this has been so stimulating. Really well done. We've run out of time, but I want to notify people that there will be a third and final research conversation this fall with Peng He, and Ting has already given us a little foreshadowing of what that will be about. So hope to see you there. Please remind other graduate students of this because it's a wonderful opportunity to learn about the research activities and interests of our faculty. Thank you very much, everyone. Shola, would you like to say anything, or Laura?
No, thank you so very much, Tingting. This is such a great, it has been such a great afternoon, and we look forward to seeing many people more at the next research conversation in November. Thank you so much. Bye.